Fanuc Alarm 8 dot, also written as SV0449 or SV0603. It is one of the most misread faults on I servo amplifiers, and getting it wrong can cost you a drive, a motor, or a full spindle. Let's break it down properly. First, the axis mapping. The digit that follows the dot on the amplifier display tells you which axis has faulted. 8 dot means the L axis, 9 dot is the M axis, A dot is the N axis. On a 2-axis amplifier, you will only ever see 8 dot or 9 dot. On a 3-axis unit, A dot is added. Next, the 2 fault codes behind the alarm. SV0449 is an IPM alarm, that is Intelligent Power Module. In plain terms, the power transistors inside the drive have detected a short circuit or an overcurrent condition on the motor output. This is instant and non-recoverable at the drive level. SV0603 is a soft thermal alarm. The amplifier has run hot for too long. Blocked fans, clogged filters, a stuck spindle, or continuous heavy cutting will all push the heatsink past its safe operating temperature. Now, the field procedure. Step 1. Do not reset and run. Every reset without a diagnosis risks another IPM event, which can take out the motor windings and backfeed into the control. Step 2. Isolate the machine, power down, and disconnect the motor power cable at the amplifier. Meg the motor windings phase to phase and phase to ground. Any reading below 1 MOhm points to a failed motor or a damaged cable, not the drive. Step 3. Inspect the amplifier fans, the cabinet filters, and the heatsink for dust. Confirm the cabinet cooling unit is running. A single blocked filter can trigger SV0603 within minutes on a hot day. Step 4. Check the DC link and the dynamic brake resistor. A failed brake resistor or a shorted regen circuit shows up as an IPM fault under deceleration. Step 5. If the motor, cabling, and cooling are all healthy, the amplifier itself has failed and must be replaced with the exact A06B spec. I drives are matched to the motor and to the CNC parameters. A near-miss part number will fault on power-up. A quick word on safety. The DC bus inside these drives holds lethal voltage for several minutes after power off. Always wait for the charge lamp to extinguish and verify with a meter before touching any terminal. Finally, replacement guidance. Genuine and refurbished A06B servo amplifiers, spindle drives, and encoders are held in UK stock, tested on Fanuc test rigs, and dispatched same day. Whether it is a legacy Alpha, an Alpha I, or an older Series 16, 18, or 21 controller, our team can...
Before touching anything, safety first. Servo amplifiers store lethal DC bus voltage on internal capacitors, often over 300 volts DC, and can hold that charge for several minutes after machine shutdown. Isolate the machine at the main disconnect, apply your lockout tag, and wait a minimum of 5 minutes. Then, with an insulated meter, measure across the DC link terminals, usually labeled P and N, and confirm the bus reads below 50 volts DC before proceeding. Next, perform a thorough visual inspection of the amplifier. Look for burn marks or discoloration on the aluminum heatsink, particularly around the IPM module area. Check for the characteristic ozone or burnt electronic smell that confirms an internal short. Inspect the power connectors, CZ2 on the 6079 or the equivalent on the 6096 for melted plastic, black soot, or loose crimps. Inspect the DC link ribbon between amplifier modules. Any visible damage almost always means the IPM has failed catastrophically. With the motor power cables disconnected at the amplifier, put a 500-volt insulation tester, a megger, across each motor phase to ground. On a healthy Fanuc Alpha or Alpha I servo motor, you should see greater than 100 MOhms phase to earth. Anything below 10 MOhms indicates winding insulation breakdown, which will destroy a replacement amplifier the moment you power it up. Also measure phase-to-phase resistance with a low ohm meter. The 3 readings should match within 5%. A shorted motor is the #1 killer of 6079 and 6096 amplifiers. With the amplifier powered off and the DC bus fully discharged, disconnect all motor cables. Set your multimeter to diode test mode. Measure between the DC plus rail and each of the 3 motor output phases, U, V, and W. Then between each phase and the DC minus rail. A healthy IPM shows a normal diode drop of around 0.4 to 0.6 volts in one direction and open circuit in the other. Any phase reading a dead short, 0 ohms in both directions, confirms the IPM transistors have failed. At that point, the amplifier needs professional repair or exchange. IPM failure is very often thermally driven. Verify the amplifier's cooling fan spins freely and moves air across the heatsink. A seized fan is a common root cause on older 6079 units. Check that the cabinet filters are clean and the internal ambient stays below 55 degrees Celsius. On Alpha I6096 modules, confirm the fan connector on the top of the unit is fully seated. A single hot summer in a dirty cabinet can push a marginal IPM over the edge and trigger alarm 8. Once the IPM is confirmed faulty, you have 3 options. First, board-level repair. Economical if you have a trusted specialist and can accept a 2 to 3 week turnaround. Second, direct exchange. Send the faulty unit and receive a fully tested, warranted replacement, usually within 24 hours. Third, outright replacement with new old stock. For legacy 6079 modules, exchange is almost always the fastest and most cost-effective route. For 6096 Alpha I, tested pre-owned units remain widely available. Whichever path you choose, never install a replacement until the motor and cabling have been fully cleared.
And cross-reference the correct part and get your machine back into production. Visit cncspares.co.uk for stock, part lookup, and technical support.